print it?
Yeah.
Yeah.
Okay, honey, you need to find a place to sit, dear.
So
Okay.
when you get older, you need bigger print.
This is my grandfather. He's a general. He's not an astronaut, but he works for Countdown Space. And he sends off satellites, and he's going to teach us about space today.
Thank you, Jack.
Nice job.
Okay, so you've all been talking about gravity today, right?
Yeah.
Okay, so we're going to talk about gravity because it's really important. Almost anything you talk about space, you need to talk about gravity first. So let's talk about gravity, and we're going to need somebody to hit the video here. Just hit the button there on my pad there. Just
Gravity is a force created by an object that pulls on another object. The bigger the object, the more gravity it has.
So Earth must have a lot of gravity because Earth is really, really big.
Correct, Nick. You got it.
So that's why everything stays on the ground. But why can't we see gravity, RT?
Great question, Sandra. We can't see gravity because gravity is invisible. We can only feel and see what gravity can do.
So, the bigger the object, the more gravity it has. And the Earth is really big, right? Really, really big. And we're going to talk about how big the Earth is. We're going to talk about how big the Sun is, too. And it's a lot bigger than the Earth. So, next slide, please. What's this?
Earth.
That's right. That's a picture of the Earth. And if you were to find us on the Earth, we'd be right about there. And this is just a picture from satellites in space that over time put this image together, and it's just a really pretty picture of our Earth.
What are those giant white spots?
Clouds. Those are storms that have formed over the Earth and formed these clouds. So next slide. Let's learn some more about the Earth here. Hit the button again.
I am the Earth, known as blue planet. My surface has water, about 70% of it. I can sustain life. Oxygen is my atmosphere. I have enough land left. 365 days in my rotation. I have a moon and food for the nation. I am the Earth. I'm the biggest planet. I spin once a day on my axis.
So how big is the Earth? Anybody know? How big?
Like, put it up to this big?
Yeah. How many miles do you think it is if we wanted to go around the Earth this way? How many miles? Guess. How many?
93 million.
Well,
25
92.
million. I was thinking probably just the sun.
That's very good. That is the distance to the sun.
25,000.
25
miles.
25,000 miles around. That's big. That's a lot of miles, isn't it? And 93 million miles to the sun. Now, why doesn't the Earth crash into the sun? Anybody know? Why?
It's far away from it.
It's far away, but there's another reason.
The Earth, scientists believe it will actually crash into the sun in 5 million years.
That's a lot of years.
Yeah.
I don't think we're going to live that long. I think we're okay. What do you think?
Gravity?
It's gravity, but it's also the speed that the Earth is moving as it rotates around the sun. It uses that speed to balance the force of the gravity. That's just like satellites around the Earth. So it's a balance of two forces. It's the speed that the Earth is moving, and it's fighting the gravity. Gravity's trying to pull it in. The speed keeps it outside the sun. So oceans cover most of the Earth, don't they?
Yeah.
What percentage? Do you remember?
70.
70%. Very good. What else does the Earth have that other planets don't have?
Nature.
Nature, yeah. How about you?
People.
People, yeah, very good.
Technology.
Technology, yeah.
I forgot.
Huh? How about our atmosphere? Oxygen? Oxygen that we breathe so that we can live. Yeah. How about
Our atmosphere.
atmosphere? Very good. Okay, so we've got water, we've got atmosphere, helps the plants and animals grow, provides our food, right? Very different from the rest of the planets in our particular solar system. How long does it take for the Earth to go around the sun?
366 days.
365.25.
1 year.
Very good, 0.25. You know that this year is a leap year, right? Because it's 365.25, every 4 years we add an extra day. So it's 365.25. This year, we get an extra day in this year to make up for that 0.25 over 4 years, okay? How long does it take for the Earth to rotate one time?
Month.
Nope.
1 day.
1 day, exactly right. 24 hours. That's how we define a day, is how long it takes the Earth to spin around. So let's talk about the moon now. Next, please. Pretty picture of the moon, isn't it? Okay, so, I'm sorry? It is taken from a satellite, exactly right. And how many sides of the moon do we get to see? How many? Right here.
1.
Just one side. That same side points to the Earth all the time. Why is that? Anybody know why? Go ahead.
Because it doesn't go, like, it doesn't change sides when it orbits the Earth.
Yeah, it spins at the same speed that it rotates around the Earth, so we always see the same side. Okay? So, how many days does it take for the Earth to rotate or to move around, to orbit around the Earth?
A month.
Yeah, well, not quite.
But like
Jack, how many days?
a year?
Nope.
29 days.
29 days, perfect. That's exactly right. No air, no oxygen, no atmosphere, no people. There have been people there, but not now.
It's basically just a bunch of rock and dust.
That's exactly right. That's what the moon is. How many miles is it from the Earth? Anybody know? How many?
I forgot.
How many?
250,000.
Not quite. Close, close.
65.
Nope, nope. 239,000. So that'd be like making 85 trips from New York City to Los Angeles. That's how far the moon is away from the Earth. A long ways, okay? You know what caused all those holes on the moon? You see all those holes? Oh, everybody knows that. That's great.
These rocks in space hit it.
Exactly right. And caused what are called what?
Craters.
Craters. Very good. Okay. Now let's talk about the sun. Let's go to the sun. Go ahead and hit that again, Jim.
Sun, 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 here I come. Sun, 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 I'm number one. Sun, 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 I am the sun. I'm a ball of super hot burning gases. Sun, 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 here I come. I shoot light and heat in all directions. Sun, 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 I'm number one. Living things on Earth need me. I'm the main source of gravity in a solar system. The planets all revolve around me.
Okay. The sun is really a what?
A
Star. It's a star, isn't it?
It's a song.
It's, I'm sorry? It's a song? Yeah, it kind of is. But it's a star. You know how many stars we have just in our galaxy? 100 billion stars. A lot of stars. But this is a special star because of what it does for us.
It's
You know-
the biggest star.
Well, no.
It's the closest star.
It's the closest star, exactly. It's not a particularly big star, but it's the right size for us because it provides us the heat that we need.
If it was any bigger, we would burn.
Exactly. If it was bigger, we would burn up, wouldn't we? Because it'd be too
If it was
hot.
smaller, we would freeze.
How big is it? Anybody know? How much bigger than Earth?
A lot
know?
bigger.
A lot bigger, that's exactly right.
About 1 million times the size.
Yeah, that's pretty close. If you took the Earth, if you could take the Earth and put it inside the sun, you could put about 1 million Earths inside the sun. That's how big it is. That's huge, isn't it? That's really big. Good thing it's not anything. Now light travels very fast. But light that's produced on the sun, because it's so far away, it takes 8 minutes to get to the Earth. That's how far away it is. How hot is it? Anybody know?
10,000 on that.
Boy, you know
10,000
all
on
this
the
stuff.
outside, about 25 million on the outside.
That's very good. Very good. Perfect. 10,000 degrees on the surface. So that's 100 times hotter than a hot tub, right?
Yeah.
So if you touch your forehead, what's normal temperature of your forehead? What is it?
About 90.
About 98.6, right? So think about that. 100 times hotter than that is the surface of the sun. So let's go to the solar system now. So this is the planets in the solar system. See how big the sun is out here compared to all the planets. Here's Earth right here. Here's Mars.
Wow, Mercury's way smaller than the sun.
Yeah, Mercury, and it gets really hot on Mercury because it's so close to the sun.
Venus is the hottest.
Venus is hotter than Mercury?
Yeah. Yeah.
Is it?
Yeah.
Due to the atmosphere,
Huh?
due to the carbon dioxide on it, it keeps the heat trapped in. That's what we learned on.
Okay.
So I don't know, we don't have the credentials as you do, we just
That's-
YouTube it.
That's good. I'm learning something here. So Pluto's way out here. So our most distant planet, and you asked me a while ago if it was why it's not a planet. It is again a planet because of some recent discoveries. That's right. It's called a dwarf planet because it is small.
Question.
Okay.
What does this mean? Right here.
That is just a little object that's way out here in the solar system,
Oh.
but it's not considered a planet.
It must be a star.
Okay. It's just
It's
a.
like a star with no heat.
No, it's not a star because it's not gases. It's a solid mass, but it's not considered a planet. It's just not big enough to be considered a planet.
What is it?
It's just an object that's in our solar system. It's just not big enough to be classified as a planet.
Was it ever a planet?
No, never was. Pluto is the one that was a planet, and then it wasn't a planet, and now it is a planet again. I'm sorry?
In 2006, it was called a planet to one planet.
Yeah, exactly, and now it's changed back, right? Okay, so this is our solar system, and just to talk about distances here, you said how long does it take for the Earth to go around the sun?
365.
65.25.
It takes
Pluto?
a year for the sun to go around the Earth.
No, Earth to go around the sun. Yeah. And then Pluto, how long do you think it takes Pluto to go around? Anybody know? You know this one too?
248 years.
Golly, he does. He's encyclopedic.
Yeah, he's the smartest person in our class. He's
That's
smarter
very good.
than
248 years is exactly right. Okay, so let's go to the next slide here. And let's play this video, Jim.
The solar system is made up of one star, a handful of planets, more than 100 moons, millions of rocky asteroids, and billions of comets. All these bodies revolve around the sun because of the gravity of the sun. Gravity of the sun is a force that pulls the objects toward the center of the sun. The sun is the only star in our solar system. It is a huge ball of fire shooting light and heat in all directions. No living thing can survive without the sun. All the planets and the moons use sun rays for their light.
Okay, remember we talked about how important gravity is? So the moon depends on the gravity of the Earth to keep it in orbit. All the planets depend on the gravity of the sun to keep them in orbit around the sun. I'm sorry?
Is it done?
Is what done?
Is the video done already?
Mm-hmm. You were looking for more?
Yeah.
You wanted more of that video? Well, there's more videos coming. Next one, please. So, if we want to explore our solar system, just a second, I'll get to you. If we want to explore our solar system, we want to get off planet Earth, and we want to look at other planets. We want to put satellites in space to study our planet. What are we going to do to get off the Earth? What do we need? What do we need to build? Right here.
A rocket.
A rocket. That's exactly right. So let's talk about rockets. Next, please. So, our rockets that we launched today with satellites on them weigh about 80 elephants. Same weight as about 80 elephants. They go about 22,000 miles per hour, which is 22 times faster than a fighter jet goes. They're about 210 feet tall, which is 1.5 times the size of the Statue of Liberty, and they weigh about the size of a Jeep, about 6,000 pounds. The satellites do weigh about 6,000 pounds. That's a lot of weight, it's a lot of speed, and it's a lot of pretty high technology. So next I'm going to show you a rocket launch, and you can help me count this down, okay? Hang on just a second.
Be a while.
I'm sorry?
Tell me off if you want to blow up.
Here it is. Go back.
Say blow up.
No, we're not going to blow this one up. Let's go. 9, 8,
7, 6,
5, 4, 3, 2, 1. Let's stop.
There it goes.
Liftoff of the United Launch Alliance Atlas V rocket carrying the second space-based infrared systems mission for the United States Air Force.
Find my duet. Look at upside down candle. Why? Yeah.
We're going to get a picture from the rocket looking back down in just a minute. There it is. That's looking back down at the launch pad.
RD-180 continues to operate well. Pump speeds are good. Injector pressures are reduced.
No people. This is just a satellite.
Is that NASA?
No, that's an Air Force rocket. We're going to talk about that just in a
You
minute.
see the beach from the picture.
There you go. Look at that. You can see the beach down there. That's down in Florida. Pretty pictures, huh? Yeah.
I was born in Florida.
Were you? Where?
Naples.
Naples, Florida. Okay. This is Cape Canaveral, Florida, which is north of where you were born. Okay, let's go to the next one and let's talk about satellites for a minute. Now this is a GPS satellite. Everybody know what GPS is?
Yeah.
Okay. All cell phones use GPS.
Yeah, it's like something that you can mine stuff with.
Yeah, like if you don't know where you're going, you can use it and it tells you where to go.
Yeah, you need to know where you're going, but
Yeah,
it tells you how to
where
get
you're
there.
going.
Miss Boyd,
Yes?
you have Miss Orange's class?
Oh, yes.
Okay, I need Helena. She's leaving.
Lainey. Thank you, she's on her way.
Thanks.
Okay, so we put satellites in space to do all kinds of things. We talked about studying the Earth. We talked about the solar system, exploring the solar system. We use it to help communicate. We use satellites to study the weather. We use it for all sorts of things. But what about if we wanted to put man into space, women into space? Let's talk about that next. So next slide. First, let's talk about satellites one more time here. Forgot about this picture. This is a picture from a satellite that's orbiting the moon. So what you see here is the surface of the moon, and the satellite is taking a picture of over the surface of the moon of the Earth. It's just a pretty neat picture. I like the picture. You guys like this picture?
Yeah.
Pretty, isn't it?
I see South America.
You see South America? Yeah. There you go.
That kind of looks like. I see Africa still there. I see Africa.
I think that's Africa, isn't it?
Africa and South America to the left.
Oh, yeah, okay. You can see South America on the far side. There we go.
Yeah.
Okay, next please. Okay, did you know that we've already sent people to the moon? Yeah. So in 1969, which is a long time ago, well before you were all born. Yeah.
I was born in 2008.
2008. Yeah. So we haven't been back to the moon for quite some time. 1972 was the last time we were on the moon. So next week. Okay, let's play this video. Watch this guy. Look at that. Okay, now let's think about this. He probably weighs 170 pounds. You all probably weigh about 50 pounds. How much do you weigh? 40, 50?
60.
80, 55.
Okay, so he probably weighs 3 times more than you, and he's got 180 pounds of equipment. And how does he jump that high? That's like 2 people, and it's like he put a person on his back and he's able to jump that high. Why? Anybody know?
When you go on the moon, you have no weight.
You have weight, but how much less weight do you have on the moon? You were close. Yeah.
There's no gravity on the moon.
Yeah, actually, it is gravity on the
Yeah,
moon, but
but not
how much?
much.
You know everything. I can't ask you yet. How much? Anybody know? How much? How much?
It's called microgravity.
It's not quite microgravity, but there's 1/6 of the gravity. So if you weigh 50 pounds on Earth, you weigh about 8.5 pounds on the moon. So stand up. Everybody stand up.
How I 55.
Okay. And just one time, listen.
I weigh 50.
Everybody jump, just one time. But you come right back down. Why? Huh? What? Gravity pulls you down. Okay, sit back down.
How much would you weigh on the moon?
With 3 pounds, so when you divide it by 6, it's about 13 and a half. Okay, so a lot less gravity on the moon, and that's the reason he's able to jump that high. So, what do we call people that go into space? Astronauts, very good. And back then, they were all men, and they were kind of small because we had small spacecraft and we had small spacesuits and all those sorts of things. But now we've got all sizes of men and women that go into space.
Small everything.
Yeah, small everything, small spaceships. So next, let's talk about, okay, that's a picture of them planting a flag on the moon, but it's also a video that we're going to play, and we're going to talk about what
After the Apollo program, which took Americans to the moon, the Space Shuttle program gave us 30 years of outstanding achievement in space. The shuttle enabled the space program to conduct space research, fly science observatories, launch satellites, and assemble the International Space Station. The station, a partnership among 5 agencies representing 15 nations, has been continuously crewed since November 2000, enabling astronauts to gain valuable insight on how to live and work in space 365 days.
Okay, so 365 days a year is what we're trying to learn how to do work in space. And why is that? Why do you think we would need to stay in space that long? It only took us about a week to go to the moon and back.
Maybe because you want to see the Earth orbit the sun.
Yeah, you could do that. What else could you do if you were going to spend that
I
long in
have a
space?
question.
Oh, okay, go ahead.
Is there something called a blue or a red giant?
There is a red giant. There's not a blue giant, but there is a red giant star. So 365 days, why would we want to know? There's an astronaut in space right now that's staying on the space station for 365 days. Why is he doing that? Anybody know? Okay. What do you think?
I forgot.
Yep. Okay, so here's the reason.
So you could learn more.
Yeah, you want to learn more, but you want to learn more about humans in space, working in space, and how long they can stay there. Because what if we want to go to Mars? That's where we want to go next, right?
It's probably going to take you like a year.
That's very good. It's going to probably take you about a year and a half to get to Mars, go down on the surface, do what we want to do, exploring Mars, and then come back home. It takes a long time to get to Mars. What about going to Pluto? Think about that. That's years going to Pluto.
20 or 30 years.
Yeah, that's a long time to get to Pluto. So we need to learn how the human body reacts to being in space for that long. So let's go ahead and talk about exploration. So this is the space station. People, as I said, living on the space station for about a year. Most people only stay there 6 months or so. But astronaut Scott Kelly from the United States is on the space station, and he'll be there for a year. So let's go on. Talk about the solar system exploration again. I just said, yeah.
Jupiter, you see, well, there's a red spot, and it's a hurricane that's been going on, I forgot, hundreds and hundreds of years.
Yeah. Yeah. Jupiter has that big red spot. Yeah.
Where's the satellite on there? Is there a satellite on there?
Well, because, how to say this? Because we're trying to show all the planets and the sun and everything else, satellites would be a little bitty speck on here, and you wouldn't even be able to see it. That's why satellites aren't on here. There are there's about 1,000 satellites that we're tracking in space right now. 1,000 active satellites that are still functioning. Yeah.
Oh. What's that right there?
That is an object between Mars and Jupiter that is a moon of Jupiter. It's big, and it orbits around Jupiter, but it's big enough that we showed it on this slide.
Is our moon on there?
Our moon's not on there because it's too small. It doesn't, again, it'd just be a little bitty speck.
How come Jupiter is a gas giant?
You mean, why is it created that way? That's just the way it formed. How the solar system actually formed, we're not really sure.
Oh.
We're not really sure how it formed.
Did an astronaut ever touch Pluto?
Nope, nobody's been out that far. Spacecraft have, satellites have been out that far, but no people have been out that far. Okay, so let's go on. Let's go ahead and play this one. This is landing on Mars. It's a rover called Curiosity.
Extraordinary men and women of NASA in our Jet Propulsion Laboratory. Right now, the wheels of Curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
So that's what the Curiosity rover looks like, and that's what the surface of Mars looks like.
So people really die.
Up in the sky?
Yeah.
I would guess that's the sun, but I'm not sure.
I guess it was probably the sun or the earth.
Yeah, could be. Okay, so why are we studying Mars? Why do we want to study Mars? Yeah?
Maybe there's life on it.
Could be life on Mars. We think, and that's why we're so curious about what's on Mars. What about our space program? What are we going to do with our space program next? The big thing that we're going to do next in the space program. Yeah, go ahead.
Why do people think there's living life on Mars?
Because the elements are there. It looks like at one point there was water on Mars. It looks like maybe there's hydrocarbons on Mars. So we think there's a potential that maybe there was life.
Yeah.
Do I personally think so? No, but we need to investigate that. And our next big thing in the United States space program is going to try to put people on Mars. So we're studying Mars. We're looking for places that we might land people on Mars. It's going to be a long time before we do it. But it took 8 months for Curiosity to get from Earth to Mars. So going back again to how long we need to stay in space, it's going to be about 16 or 18 months for a manned space mission to go to Mars. So next, please. This is a picture of Pluto.
Pluto?
Yeah, and that picture we just got about 6 months ago.
That looks... I see the big red spot.
That's a different planet. This is Pluto. This is that planet that's way out in the solar system, the last planet out in the solar system. Now, the spacecraft that got to Pluto and took these pictures is called New Horizons.
Knew that.
When do you think it was launched?
On like
What year? Go ahead.
2014.
Much longer ago.
2000 something, and it was like when my mom was about, and dad was about, was like just about the age of us.
Yeah, it was a long time
Maybe a
ago.
little younger. And this is one.
Go ahead.
Maybe 1990s,
No, not it. 2006.
Oh, I was guessing
2006. Yep, 2006. So that's right. It was before all of you were born. The spacecraft just got there this year. So that tells you how long it takes to get out to Pluto. So if you wanted to send man out to Pluto, man and women out to Pluto, it would take a long time, wouldn't it? Take many, many years. Okay,
So they have to bring a lot of water.
they sure would, or figure out a way to produce it. And we haven't figured all that out yet. And that's why it'll take us so long to get to Mars, to do a Mars mission, because we've got to figure out all those kinds of things, because it's going to be a long time in space. Okay, I've got one last video to show you, and the reason I'm going to show you this last video is because it is really cool to work in space. It's cool to work on the space program. It's cool to be an astronaut, and hopefully you've got the same idea about that. If you work hard, if you do well in math, and you do well in science, you too could be an astronaut. So let's play that video. Okay, questions?
Have you ever been out of space?
I've been to space, no. No, I worked on the space shuttle program, but I didn't get to go on the space shuttle, unfortunately.
Did you ever get to like see inside the space shuttle?
Mm-hmm, I did.
Why is one of the planets go like on their rings go on sideways? Uranus?
Why are the rings on there?
I mean, why is it tilted?
That's a good question. I don't know. We'll have to figure that one out. I don't know the answer to that question.
Do astronauts wear diapers? Yes.
Yeah, the answer is yes. But it's only when they're launching into space, because they go for the space shuttle. They were laying in the space shuttle for about 2 hours before launch, and so that just gave them a way to go to the bathroom if they had to, because they couldn't get up. Yeah.
I forgot.
Okay. Yeah.
Why does it have to be stars in space?
I couldn't hear the question.
Why does it have to be stars in space?
Why do there have to be stars in space? I don't know that there has to be stars in space, but it's sure pretty to look at. If you go up at night, on a clear night, and look up, you see lots of stars, don't you?
Yeah.
And that's just the way the whole universe was created. Yeah. You have a question?
Did you ever help people build a spaceship?
Mm-hmm. Yeah.
And did from all the iron from the spaceship that came off, is that like the iron that hit the moon?
It's not really iron. It's really, you know what aluminum is?
Yeah.
You know what foil is that your mom uses for cooking? It's just thicker. That's aluminum foil. So it's just thicker aluminum, and spaceships are made of that. A lot of other things too, but mostly aluminum. Yeah.
So some scientists believe why one planet is tilted because asteroids hit it.
Could be. If a big asteroid hit it, it could cause it to tilt. But I don't know. I should know the answer, but I don't.
Why is Pluto like the farthest planet away from the sun?
Just the way the universe was created. Pluto ended up way out there. We're lucky we ended up where we did, so we didn't burn up or freeze.
How come stars twinkle?
Why do they twinkle? The atmosphere of the Earth causes them to twinkle. As the light comes through the atmosphere of the Earth, it twinkles. But it doesn't for planets, because stars are producing light themselves as opposed to reflected light, and the planets are showing you reflected light, so that doesn't twinkle. Okay. Do you remember?
Yeah.
Good.
It's sort of what Cody said. And they in a video, they said that some scientists believe it's up and down because a big thing in space hit it and then it turned.
Big asteroid hit it?
Yeah.
Could be. Could be. That could have caused it. Okay. Thank you for your attention. You have one last question?
The tilted planet could have just been made like that.
Well, I suppose, but it's really unusual that it's tilted like it is, so we'll have to figure it out. I'll look that up and we'll see if Ms. Voigt can get you the answer to the question, okay? Okay, thank you. I enjoyed talking to you.
What do you guys say to Mr. Shelton?
Thank you.
I think he deserves a round of applause. What do you guys say?
You can thank Jack. Jack asked me
Do
to
you
do
have
it.
Claire in your class?
I do.
Mom's here to pick her up early.
Okay, great.
Yeah.
All right, what do we say to Claire?
Bye, Claire.
We were interrupted. Mr. Shelton was saying there was a special person that asked him to come in, and who was that special person?
Jack.
So what do we say to Jack?
Thank you, Jack.